Hello everyone, in this video we're going to go over the solutions for test 3. So first let's go over the multiple choice questions. On the first question we find all the solutions for e to the 3x minus 5 equals e. So what we do is we apply the log on both sides so we can actually cancel the exponentials. This log of e to the 3x minus 5 is just going to give me 3x minus 5 once that I cancel the log with the e. Log with the e here cancel and it leaves me 1, and so I get 3x is equals 6 or x is equals 2. So this is answer A. For B, it's a similar situation, but you have log of x plus 5 equals 2, so instead of using the log with the e, we're gonna use the exponential to get rid of the log. And so we get now e to the log of x plus 5 equals to e power 2. And we cancel the e with the log, and we get x plus 5 equals e to the 2, and x is e to the 2 minus 5. So that is answer C. When we see number 3, we have what is the t value corresponding to the point minus 1/2 minus the square root of 3 over 2 in the unit circle. Notice that this is a point that is on the third quadrant, so that's going to inform what we're looking for. And of course, you can use the unit circle that was provided in the exam. Let me see if I have it over here. Yeah, the unit circle. Yeah. So this is in the third quadrant. You're looking to look for this point, and this is going to be 4 pi over 3, which is answer E. Okay, now moving on, question number 4. Question number 4 asks me for what is sine of 13 pi over 6. Notice that this is 1 pi over 6 more than 12 pi over 6, which is 2 pi. So this means that this can be done with a coterminal angle. This is equivalent to sine of pi over 6. Once again, if you want to, you can use just the unit circle, and we're going to find that the sine is 1/2. So that is answer D. Now, number 5 is for a circle of radius 5, what is the length of the arc with the central angle 30? So first, we establish that S, the arc, is r times theta, with r is the radius, which is 5, and theta gotta be the angle, but theta gotta be in terms of radians. So 30 is pi over 6, and so this will be 5 pi over 6 overall. Which is answer D. Moving on, question 6. So we have now what is the value of sine to the minus 1 of sine of 5 pi over 6. Turns out that you gotta remember that sine to the minus 1 goes from minus 1 to 1 to the interval minus pi half to pi half. So we gotta make sure that whatever we get at the end of this question, it should be a value here. But we can use what is the sine of pi over 6. Of course, that sounds pi over 6. That sounds like it's going to be an angle that is going to be in the second quadrant. Since it's before that pi, which is 6 pi over 6. You can see that 5 pi over 6, the sine is going to produce a 1/2. So we get sine to the minus 1 of 1/2, and that's going to be certain theta, right? That's the angle that we're gonna get, and so this means that the sine of theta should be 1/2. But we know that this gotta be on the first or on fourth quadrant because that's pi half minus pi half to pi half. So that means that we gotta look for where do I get the sine being 1/2 on the first quadrant, which is in pi over 6. So in this case, we find that theta is pi over 6, which is answer C. Okay. Now number 7 is about log equations. So we have that we can fold this first by properties of the product. This is log of x minus 2 times x equals to log of phi x. We apply exponentials on both sides to get rid of the log, and we get that x squared minus 2x is equals to phi x, or equivalently x squared minus 7x is equals to 0, x minus 7 is equals to 0. And so x is equals 0 or x is equals 7. Since x cannot be 0 because we cannot plug 0 on the logs here and here, then the answer is going to be C with only 7. Now question number A is the right triangle with an acute angle has a hypotenuse of like 10. Find x. X is the opposite, and so we have a relationship between opposite, hypotenuse, and angle. So that calls for the sine of 30. Sine of 30 is opposite over hypotenuse, and so we can say that 10 sine of 30 degrees is going to be x. And so of course sine of 30 we can find out from our unit circle, which is going to be 1/2, and so this is going to be x equals 5. Question number 9. So this is a similar graph to what we had in test 2, and it asked me for describing what is the what is this log describing. One of the things that you gotta know is that the log of 1 is 0. So this means that whenever you're plugging in -2, you're getting log of 1. So you gotta look for something that when you plug -2, it gives you log of 1, which in this case seems to be this, right? So when you plug -2, then you get log of 1, which is 0. Also, this tells me that the asymptote is at -3, which it fits with the graph. So that's the candidate that helps us for this. Now, let's compare 160 degrees to radians. So this is not something that we can get from the unit circle, but we can say, well, 160 is equals to x, and we know that 180 is pi. So we can kind of simplify here. 16 over 8 pi is x, and if we simplify more, we get 8 over 9 pi is x, and this is just answer B. Okay. All right, moving on, we have next that we want to find out what is cosine to the -1 of minus the square root of 3 over 2. And so the way that we do this is we imagine that this is certain theta, and so now we're looking for when the cosine of theta is minus the square root of 3 over 2. Cosine is the x, so this means that this can happen only on the second quadrant or in the third quadrant. But we also know that cosine to the -1 goes from -1 to 1 to 0 to pi. So this gotta be an angle that is on the first or second quadrant. So now we go to our unit circle and we'll look for an angle on the second quadrant so that the cosine gives me minus the square root of 3 over 2. Oh, we find out that it's 5 pi over 6. Question 12. We have for an acute angle, so first quadrant, we're given the sine of theta is 4 over 5, find tangent of theta. We can do this with the triangle. So we have triangle here, we have the hypotenuse is 5, we have that the opposite is 4. We don't know how much this guy is, but we can use the triangle. We have that 5 squared is equals to 4 squared plus x squared. And so 25 minus 16 is equals x squared. And so 9 is equals x squared. And so x is equals 3, since it gotta be positive by being in the first quadrant. And so if this is the adjacent, the cosine of theta is going to be 3 over 5. And the tangent of theta, which is sine over cosine, is going to be 4 over 5 over 3 over 5. So it's going to end up being 4 over 3. Okay? Now, number 13 is which of the following describes this graph? Notice that this looks like a tangent since this is increasing from left to right, but it doesn't have an asymptote at minus pi half and pi half. Instead, it seems to have asymptote at 0 and pi. And now it doesn't have a 0 at 0, but it has a 0 at pi half. So this means that we're taking the tangent and we're moving it pi half units. So this is my answer, tangent x minus pi half, which is moving the tangent pi half units to the right. Now let's go to number 12, write true or false for this following fill in the blanks. this square root of 1 minus sinus square is false. We cannot distribute the root in each of the components, so this is false. Cosine of x equals 1 over secant of x is true, since secant of x is actually 1 over cosine. So we can kind of flip the positioning, and it's done. Now, tangent of minus 1 of 5 pi over 4. 5 pi over 4 is an angle that is in the third quadrant. And so this will be saying tangent of 5 pi over 4 is minus 1. But we know that this is not true, because when we look 5 pi over 4, x and y are the same thing. So the ratio is going to be 1, not minus 1. So this is false. The graph of y equals tangent of x has an asymptote at pi half. Yeah, we know that that is true. And the graph of the cosine can be obtained from the graph of sine, shifting the sign horizontally pi units to the left. This is going to be true. Now, this is something that you can definitely check from here, because notice that if you start with sine, this is what we have, but we want to obtain cosine. So if we subtract pi half, it's not. Notice that this is like a minus cosine, but if we put a plus, if we're moving it to the right side, to the left side, sorry, then we get that now it matches the behavior of the cosine. So this is true. Now, question 15 is about finding range, amplitude, period, all that for this function. And we have both the function and we have the graph. Now, from the range, we can see that it goes from minus 3 to 5, just from here. From minus 3 to 5, we have a distance of 8, so the amplitude is going to be 4, which matches with this. The period, the distance between two maximums is pi, which matches with if I do period equals to pi over 2, because we have this 2 here, so this is pi. Horizontal shift, we don't have a shift here, so this will be none. And vertical shift, notice that this is not going from minus 4 to 4, but is going from now minus 3 to 5, and we have a plus 1 here, so the vertical shift is 1 up. Okay? Now, question 16. For question 16, we just need to identify who are the correct graphs. So this is just identifying, hey, A is the graph of the sine, so this should be 4. B is the graph of the cosine. And now 1 over sine is cosecant, so this matches with C. Notice that it should match, this thing should match this here. They kind of should kiss the maximums with the minimums in here. So C is going to be the cosecant, and in the same way D is going to be the secant, which is 1 over cosine. Tangent is going to be the E, which is increasing from left to right, and F is going to be the cotangent, is going from here to here. Now, last question is the standard response. So we have that the population of small Ohio in 2010 was 14,000. So this means that in 2010, we're going to classify as t equals 0, and the population was 4,000. So P0 was this. And so we can kind of write what this is. We're growing 10% per year. So 10%, remember, is 10 over 100, which is 0.1. So the function here that we can establish is P of t equals 4,000, which is the initial population P0, exponential to the 0.1 t. Now, question number 2 says, how many years after 2010 will the population reach 8,000? So we say, well, 8,000 is going to be P of certain time t, big T, and that's going to be, of course, 4,000 e to the 0.1, whatever that t is. If you divide, we need to solve for t, so we divide 8,000 by 4,000, which, by the way, is going to be 2. And this is equals to e to the 0.1 t. And so that means that if I take the log of 2 is 0.1 t. 0.1 is like 1 over 10. So now I can say that t is 10 log of 2. Or if you want to, you can also see this as log of 2 divided by 0.1. Any of the two answers is okay. Now, question C is, using the model above, how many people will be there in Yellow Springs in 2025? This is when t equals 15, so you just need to plug p of 15, and this will be 4,000 e to the 0.1 times 15, and this will be 4,000 e to the 1.5. And that's it. These are the solutions for the test tray.